As we've been studying limits, we've always looked at what's happening as the function approaches our x value from the left and what happens when our function approaches the y value from the right. Today we're going to be looking at one-sided limits. At the end of this lesson, you'll be able to find the limit from one side of a function. All right, the first thing that we're going to do is look at the definition of what is a one-sided limit. It's basically just, instead of looking at from the left and looking at from the right, you're just going to look at one or the other, not both. This first definition, you'll notice it just says the left limit. Looks very similar to what we've already been working with, but you'll notice there's a little negative sign. That means I'm only going to approach from the left. All right, so we're just going to put a little arrow. We're just coming in from the left. Our right limit, you'll notice it looks very similar to our other definition. Again, there's just a little plus sign. So if you see a plus sign, we are just going to be looking at what's happening as we're approaching from the right. The easiest thing, just like we've been doing on the other problems, is just take your pencil or your finger and just either start from the right or start from the left and do exactly what it says. And we've already dealt with this before, but I am going to make the note. In order for a limit to exist, the limit from the left must equal the limit from the right. So if those two don't match, just like we're used to, the limit does not exist. Let's look at an example. This one, it asks us to find the limit. You'll notice the first one, it asks us to find the limit as x approaches 3, and then there's a little negative sign. That means that we're going to be approaching just from the left. So as I'm getting to x equals 3, I'm going to draw a dotted line at x equals 3 because sometimes that helps people. We're going to stop when I get to that line. So I'm going to approach from the left. So notice I'm approaching from the left. I'm going to stop when I get to that dotted line, and notice the y value that I'm getting close to is 0. So that limit as I'm approaching from the left is 0. The next one asks me to find the limit as x approaches 3, and there's a plus, so that means approach from the right. So again, I'm going to be approaching from the right, approaching from the right, and I'm going to stop when I get to x equals 3. The y value that, the y value that I'm very close to is 1 this time. We approached from the right, and that y value was 1. Okay, so now we already know this answer because we're used to dealing with if it's not approaching the same y value from the left and the right, the limit does not exist. So definitely on this one, if it asks me just to find the limit as x approaches 3, we know that it does not exist. Okay, the one thing that we're going to be looking at now, so far I've just allowed you to write the limit does not exist. From now on, we always have to say, why does it not exist? So my reasoning will be because, and this is just shorthand for because, if you'd like to write it that way as well. Why does it not exist? Because the limit as x approaches 3 from the left does not equal the limit as x approaches 3 from the right. So that will be our reasoning from now on if a limit does not exist. All right, let's look at another example. This time you'll notice it says let's find the limit as x approaches 2 from the left again. So as I'm approaching, here's x equals 2. As I'm approaching x equals 2, notice the y value that I'm getting closer to is 2. Now the next one says limit as x approaches 2 from the right. So I'm approaching from the right. I'll stop when I get to x equals 2. The y value that I'm getting close to is 2. And we already know that if our limit from our left and our limit from the right equal the same thing, then that is our limit. So our limit is equal to 2. So you'll really notice there's nothing new that we're doing in these problems. We're just formalizing what we're doing, and we're actually being able to write it in a mathematical statement that we're finding out what's happening from the left and what's happening from the right. All right, the next example you'll notice, this just says to find the limit as x approaches 4 from the left. So we actually are going to graph that. So just give me a minute here, and you can go ahead and graph this on your calculator, and I'll graph it on mine. So now we are going to go ahead and graph it. The graph was the square root of x divided by x minus 4. So that's what I'm going to type into my calculator, square root x divided by x minus 4. Okay, and then I can go ahead and press graph. Probably I'm going to hit zoom 6 just in case I'm not on my standard window. So there we go. You'll notice that we have a nice asymptote happening at 4, and then we've got that graph. So now I'm going to go back to my program, and I'm going to go ahead and graph that, if I recall correctly here. I had something that looked like that. And so now it only asks me, it doesn't ask me for the limit, it just asks me the limit as x approaches 4 from the left. So here's x equals 4. I'm just approaching from the left, and as I'm approaching from the left, I'm headed towards negative infinity. So that would be my answer. Please notice that I can really tell that the limit does not exist, but from the left, I do get an answer. All right, new problem. This time you'll notice that we have a piecewise function, so we have something different happening from different sides. So you'll notice we would like to find the limit as x approaches 2 of this function, right? We need to figure out, first of all, we don't have a picture. We can't just plug in 2 because we have two different things going on. So what we need to figure out, we know that a limit exists if the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. So we actually have to find these values, and then if they equal each other, that will be our limit. So the limit as x approaches 2 from the left would be all the numbers that are less than 2. So to find that limit, I'm actually going to use this top function that will be approaching 2 from the left. So just like we do in normal functions, we're going to use direct substitution, and we're going to put 2 in that problem. So negative 2 times 2 is equal to negative 4. Okay, now we're going to find the limit as x approaches 2 from the right, and 2 from the right would be 3, 4, 5, 6, which would be all values bigger than 2. So we're going to use the second part of the function, and I'll go ahead again, use direct substitution, and just plug 2 in for all the x's. And when I do that, looks like I get negative 3. So you'll notice that the limit from the left did not equal the limit from the right, and because the limit from the left did not equal the limit from the right, we can put that the limit does not exist. All right, one last problem. Consider the function g of x is equal to another piecewise function. What does a have to be in order for the function to be continuous? All right, if you remember back to our conditions for being continuous, the first one was that f of whatever has to exist, and actually we'll use g this time. All right, so g, and how do you pick your x value? Well, I can kind of tell things are going on at x equals 3 because that's where the formula switches from one to the other. So we're going to see, is g of 3 defined? And I notice there is an equal sign underneath here, which means that formula says when I'm going to use that when x equals 3. So I'm going to use that formula. G of 3 is defined because there is that equal sign there. So there must be a dot or point somewhere there. Okay, the next thing, and actually I can look at, we could actually plug 3 in, and that would actually equal 7. Okay, next thing, we know that the limit as x approaches 3 has to exist. All right, well, how do we find if the limit exists? Just like we did on that last problem, we're going to find the limit as x approaches 3 from the left. We know that that would have to equal the limit as x approached 3 from the right. So again, just like we did in that last problem, we're going to actually go find these. So as it approaches from the left would be values that are less than 3, so I'm going to go ahead and use the top formula. If I plug 3 in for my x, notice I'm just leaving my a alone because I don't know what a is, I will get 12 plus a. Okay, now if I approach from the right of 3, that would be from all of the numbers that are bigger than 3. So I'll use that second formula. So I'll have 3 times 3 minus 2. Notice we get that that's 7. All right, we're not finding if there is a limit. We know there has to be one because it tells us that we want a continuous function. So those limits have to equal each other. So we can just go ahead and put an equal sign in between the two. Solving for a, I would know that a would have to equal negative 12. So that's how we would find that answer. So hopefully now you're very comfortable with one-sided limits.